This may look like a pile of junk, and at the moment it is a pile of junk. This is a rigid compound slide saw. It's the 12-inch version. And I like this saw. I really like the base on it. That's the reason I got it. It was also a good deal, but for good reason. It was in the worst shape of any tool I've ever purchased, and I buy a lot of old machines and I like to put some work into them and get them fixed up. But there are some parts that are broken on this, and I think we can use 3D printing at least for one of those parts. So I thought this would be a great time to show how I would take those parts off, take the measurements, take the 3D scans or whatever, and make the replacement part. We'll print it and test it as well. Quite a bit more force. So stick around. I want to focus on 3D printing in this video, but I do want to show you just how bad a shape the saw really is in before we get to that. What have I gotten myself into? I picked up this off of Facebook Marketplace. This is the Rigid MS 1290 LZA, huge base. It's not quite as heavy as you'd think. I went to look at this and I thought this was a really good price, but as I got it home, I realized why it was such a good price. It's got a lot of problems. I have a compound miter saw, Milwaukee, and it's been working well for me for a lot of years. But what I like about the rigid saw is, the size of this base. Sometimes the Milwaukee is a little bit small. This one is huge. There's a lot of support. I think we can get some of it fixed, but we're gonna need some new parts here. This is not working. Does not want to release, and I can't change the angle. There's a 10-inch saw blade on here rather than a 12-inch, which I think is why the guard has been disabled. You can see the arm for the guard is back there. I don't know what's going on with that. There's this solution with the string. This piece is broken off, which looks to me like it might have just been a cord wrap. It might be missing the dust chute, but that's easy to 3D print. The lever back here for the tilt lock or bevel lock is broken off. You see the wire back here is not looking in great shape either. There's quite a bit of corrosion, possibly left outside. So I think this is going to be a full disassembly. Everything should be cleaned. Everything is going to be polished up. So let's get into it. These look like threads, but actually they're not. They're just really gummed up springs. There's a little bit of rust on these rods, and that's preventing these from moving, passing through this aluminum brake here properly and smoothly. So the previous owner of the saw said that these screws were all stripped. I'm going to be really careful when I do this. I have this manual impact driver, and I can give that a couple more whacks. Yep, the head broke off of that one. Initially, I wasn't thinking about using 3D printing for this. I was going to order new parts. I might be able to 3D print these pieces. These are really thin and flimsy. The only issue with 3D printing these parts is the length, and there might be a way that we can join them. And this is also pretty consumable on these saws, so I think this probably is a good example. But let me show you the real issue here. Look at this lever. Absolutely horrible, horrible shape. This saw was abused. There's a lot wrong with this. This lever is not usable. It's really sharp. So what we need to do first is get this thing off and see if we can have a look at what it's supposed to look like. And then we'll take some 3D scans and some measurements as well and see if we can come up with a new one, one that will never break again. So this is all cleaned up. We can have a close look at it now, and it's not really that complicated. But we are missing a piece. We're gonna have to use our imagination a little bit for this, or maybe some photos from online to see what it's supposed to look like. I would have thought this was glass fiber reinforced, but I'm not 100% sure. There's definitely been some use of glue on here. You can see that the glue had dripped down. So let's get our measurements. I was able to find a photo of what this should look like, so I think we're going to try and reproduce it as close as we can, even the length of the arm, the angles, and all the extra little details. So let's go ahead and get into Fusion and see if we can reproduce this as close as we can to the original. First thing that I want to do is take the dimensions that I took and transfer them into Fusion, and I'm going to try and draw a circle around this circle, because I think it is just two circles that are not concentric with each other. But I'm finding out that the dimensions I took the first time don't seem to be quite working out that way. So I'm going to come back to this in a minute. And in the meantime, I'm going to draw the lever arm, or a very basic version of that lever arm. It's extending off there. You can't see it on screen, but I was continuously referencing the Walmart picture. So now I'm taking some measurements again, because I found out the first time that I did it, I wasn't precise enough with the calipers. This time I'm being much more careful, and it was able to get me quite a bit closer to having two circles that actually worked out properly rather than a series of arcs. I'm just refining the shape and the length a little bit to try and bring it as close to the original as I can. And there is a fairly large embossed area here. I don't think it's completely necessary to do this, but the original had it and I wanted to reproduce it as well. I'm going to extrude it up, but I'm going to actually extrude it further than what I need, and then we will go ahead and cut out a region because there's a little extension off to one side. I think the shape is getting pretty close, so we can add in some raised sections and we can add in some of these embossed areas as well. Now, while I'm designing this, I am thinking about how this is going to be 3D printed. I want to print this laying on its side, just like you see it on screen here. That's going to be really strong in the final product. So when I am creating these embossed areas or raised areas, I'm also chamfering all of the edges just to make sure that it can easily print. I'm not going to have an issue with overhangs or bridges and things like that. Now I'm going to show you something I don't think I've ever seen done before, and that is to use a software called Glass 2K. What that allows you to do is change the opacity of your program so you can see directly through to what's behind it. So in my case, I'm going to put Fusion in front. I'm going to have the picture behind it, try and line them up as close as I can. That allows me to continuously reference it. When I make a little change, I can instantly see whether that change was the right direction, the right angle, the right fillet size, or whatever it may be. So I'm just going to go ahead and make a couple more tweaks, and then we're going to be able to, with this technique, get it really, really close. Once I've got it to a point where I like it, I'm going to go ahead and print a prototype. I'm not going to print the final version yet. I'm going to print a PLA version, really lightweight, just to make sure that I can test it without wasting too much material, and that the lever arm actually works correctly with this off-center circle mechanism. I think what I'm going to do now is just adjust this a little bit and make sure that it can apply the right amount of pressure, that I don't need to make any other adjustments to it. But everything else looks pretty good. It sits down in the right position. When it goes in the up position, it can't go too far either. And at least the front section of the original one looks about the same. Okay, I think we've got it, just the right amount of force. So I'm pretty happy with that. I think that we can go ahead and make the final part. So to do that, I'm going to use a material that I've never tried before, and it's this one, PA12 carbon fiber. It's black, so it's not quite the same color. I would prefer a dark gray, but I will take it. So this being nylon, I'm going to dry this before I even try and print with it. In a previous video, I went ahead and punctured one of these, and you guys pointed out that it was resealable. And I got some flack in the comments for that. So this one does not look like it's resealable. No Ziploc there. This is the rough flow rate calibration, and number 20 looks the best to me. 20 will bring us to 1.15. That's the most I've ever had to enter. I'm going to go one step further and do the perfectionist version of the flow rate calibration in Orca Slicer. Because I'm going to have a 100% solid part, it is critical. It is really important to have a proper flow rate, otherwise there's no place for the material to go. If you're under extruding, that's a different issue. Not really a good problem to have though either. We want to be bang on if we can. And for the perfectionist, it looks to me like negative 0.04 is the one, maybe even negative 0.05, but that's probably pretty close to what is going to get us the best result. We are at about 11 millimeters for the right height for PA. The seam looks pretty good at 11 millimeters as well. So 11 millimeters times 0.002 is 0.022 for the PA, and I had it set at 0.035. Go ahead and make that change, and then we'll get our print going finally. 0.022, save that. Okay, I'm in Orca Slicer right now. I've got the lever arm in, and I'm going to flip it around. I've got the correct material selected, and I want to have this. It's not a huge problem if we have 5 walls, but I think more walls is better, and we're going to go with 100% infill. That looks good. I think we're ready. This is going to preheat for a while. The drying cycle has finished. I'm just going to leave it as is, completely closed. I've plugged up all the holes, and we should be good to go. We'll come back in a few hours when it's ready. That is strong. So if I calibrated this properly, the pin should fit in still. Ooh, that is a perfect fit. Okay, it's time to get this mounted. And let's see. Oh yeah, quite a bit more force on that. Beautiful. That feels good. Yeah, that feels pretty good. Sometimes these can be a little bit nerve-wracking because there really is no room for error on this, especially because I'm using a brand new material I've never used before. So now we can turn our attention to the next set of broken parts. So we have these plastic throat plates. They are adjustable, and you can see they've taken some abuse. These are completely cracked. I mean, technically it is still usable, but I think they really should be replaced. So immediately what I notice is that the gap is way too large here. Now these can be brought in. One of the issues with doing that is that there's no way for the sawdust to escape easily. We could probably address that in the design. So the first thing I want to do is start with a 3D scan of this area. So I'm going to start by just using some painter's tape. And this just helps the software to differentiate a little bit as we move around. And I usually like to go one step further and draw some different shapes on here. Okay, I'm going to use Polycam. So what I like to do first is start with kind of the overall. And then I'll get in close and make sure that I've got all the details. So we could say done, and we can say full, and object masking, sure, I think it should work in this case. Upload and process. It just finished, and that is the end result. Now you have to be careful with these sometimes because the texturing can really throw you off. It makes it look so good, but when you change it over and look at the mesh, it doesn't look good. But in this case, it actually does still look really good. It looks like it's captured all the details that we need. So now we can just export this and bring it into Fusion. I'll probably trim off what I don't need, and then we can just work with that. So this is what we need to work around. We just need to make sure that we can get this thing installed while the fence is in place, like the originals. And I think I'd like to make a little improvement as well. When they manufacture these, they make them exactly the same, left and right. So they can just be flipped around. That makes quite a bit of sense. But when it comes to dust collection and all the debris that builds up inside here, it doesn't make much sense. Because with these in place, it's too hard to get the material out of there. You're trying to scoop it out with something that goes in between, or you have to pop these off. And as we saw with the ones that I tried to remove, they were all rusted and mangled. So that doesn't make a lot of sense either. So I think this is going to be a larger opening back here, which is also going to promote better dust collection. A lot of the dust from the bottom should come up a bit easier and hopefully be picked up by the dust port at the back. The next thing that we should do is align this to the different planes. That way it's going to be a lot easier to work with. Trim off anything that I don't need to see and don't need to use. It's going to simplify everything for us. Now we want to confirm that we have the overall scale correct. So I'm going to measure the longest point, 491.25. 491.25 millimeters. 115 millimeters for the width. Now it's just a matter of tracing it and making the shape that we want. I'm always tempted to try and get it to be a tight fit, but that's always where I go wrong. So it's better to leave a little bit more space, 0.5 millimeter on each side. So 1 millimeter overall is probably a good number to use. That way it fits properly. And with something like this, there are going to be draft angles on there too. So the deeper it goes, the tighter it will tend to get. I jumped ahead just a little bit. I've already covered the connection in the previous video. So these are 2 of the finished parts. This is one of them. It's just ordinary gray PETG. So we've got an interlocking dovetail connection. In this case, I have scarfed it, but only in one direction. In a previous video, I've shown that you can also tilt it on an angle this way so it's on a compound. So this dovetail fits into this piece, and it's supposed to be glue connection, so not too tight. Though I think I'll make a little change on the next one. The height looks good. In order to get this to bridge properly, I created a very thin layer that spans the entire hole. So that is easy to push through when I put the screw through. And that just helps to make sure that no supports are required in there. The other thing I've done is I've recessed these in the back, and that way they fit over top of the raised sections, and it provides a lot more support when I put the screws in. The original did not have that. The original only had a completely flat section, which means it was more or less pivoting. It could pivot, providing really poor support. With this, when the screws are in, it should lock it in place really nicely. Side by side, you can see the gap is much smaller than it was originally. I've just gone ahead and used some super glue to connect this together. I'm going to let that set, and then I'm going to go ahead and print the other one with a little bit tighter connection, and then we are almost ready to test this baby out. We're pretty much done. Just need to put these two pieces together. So the last time the joint was a little bit loose. This time I have tightened it up a bit, but I've done one more thing, and I have this now at a compound angle. That's pretty darn good. I'll tighten it up by maybe 0.02, but I think this will be plenty good for what we need. There we have it, the first version, the single scarf, and this version, the double scarf. It's on a compound angle, so that's pretty cool. This should be just slightly tighter, and part of the way that I've set this up too is that this piece, even if it weren't glued in place, cannot lift up. It can't come out. Pretty nice. Unfortunately, I didn't have the orange color. Maybe eventually I can reprint this in orange, but pretty happy with how this turned out. And this, by the way, is available for free for anybody to download. The link will be down there below. And for the other part, we started with this piece and ended up with this heavy-duty lever arm. When we push down on the lever arm, this aluminum piece is flexing, and it does seem to be working really well. So I think this is going to work out just perfect. It definitely seems stiff. Need to plug it in first. Oh my God. Okay, this is an outdoor saw. Wow, that is a ton of sawdust. Well, there's the next project. we need to add on a feature that has the ability to collect some dust because this is not acceptable. If you'd like to print any of these models, they are available for free to download in the link below. Next week, I have a very special video for you guys. It's going to involve what's in this box, what's in this one, and a little sneak peek, these 3 different metals as well. I want to say thank you to each of my patrons for helping to make these videos possible, and thank you for watching. Take care, and we will see you on the next one.